So we are just revising reflection of light. Okay. Now different surfaces reflect light to different extent, है ना? जो we have different surfaces and these different surfaces reflect light to different extent. Okay. A highly polished and silvered surface such as plane mirror reflects almost the entire light falling on it. ठीक है ना? So जो we know that the different surfaces will reflect light to different extent. If we have a polished surface, there will be more reflection. If we have a dull surface, है ना, or uneven surface, the reflection will be less. So a highly polished and silvered surface such as a plane mirror reflects almost the entire light falling on it, मतलब almost 100% reflection. A plane mirror is made from A plane mirror is made from a few thick glass plate. So one surface of glass plate is polished to a high degree of smoothness. This forms the front surface of mirror, and the other or back surface is silvered, that is silver, mercury or some suitable material is deposited over it. The silvered surface is further coated. So how we making the plane mirror, that is being explained here. So try and understand. So a plane mirror, how is it made? It is made by a few thick glass plate, है ना? एक एक few thick glass plate है ये, जैसे आपको glass plate दिख रहा है, few thick glass plate. One surface of the glass plate is polished to high degree of smoothness. This forms the front surface. तो ये वाला जो surface है इसको highly polished surface है, polished to high. So this forms the front surface of mirror and the other surface is silvered. पीछे वाला जो surface है इसके पीछे एक silver का coating कर देते हैं, basically silvered. Silver or mercury or some suitable material is deposited over it. In that, मतलब एक foil जैसा होता है वो हम लोग उसके ऊपर paste कर देते हैं. The silvered surface is further coated with some opaque material so as to protect the silvering on it. अब ये silvering तो remove हो सकता है कि कोई भी अगर उसको touch करेगा और ऐसे नाखून से भी ऐसे करेगा तो remove हो जाएगा, right? तो उसको protect करने के लिए हम लोग क्या करते हैं, पीछे एक हम लोग opaque material से coat कर देते हैं, paint जैसा होता है, rusty color का, generally rust color का, जिससे कि हम लोग उसके पीछे coating कर देते हैं. So light enters from the side of polished surface and is strongly reflected from the silvered surface. तो ये जो polished surface से हमारा light polished surface से enter करेगा और silvered surface से वापस reflect करेगा. The coating serves as an opaque surface and it does not reflect the light. So coating does not reflect the light, but it is the silvered surface which reflects the light. Now, kinds of reflection. There are two kinds of reflection. So there are the following two kinds of reflection. One is regular reflection and other is irregular reflection. ठीक है, दो तरीके का रिफ्लेक्शन है, एक रेगुलर रिफ्लेक्शन है और एक इरेगुलर रिफ्लेक्शन है. ठीक है. नाउ रेगुलर रिफ्लेक्शन क्या है? रेगुलर रिफ्लेक्शन में regular reflection occurs when a beam of light falls on a smooth and polished surface such as a plane mirror. ठीक है, तो ये आप रेगुलर रिफ्लेक्शन, एक प्लेन मिरर है, तो जो अगर पैरेलल रेज ऑफ लाइट gets reflected from a regular surface, it gets reflected in a parallel beam only. So regular reflection occurs when a beam of light falls on a smooth and polished surface such as plane mirror. In this figure, where regular reflection is happening, a parallel beam of light is incident on a plane mirror. The reflected beam is also parallel and it is in a fixed direction. So each of these reflected rays, they are also parallel and it is also again in a fixed direction. So it can be seen only from a particular direction. Okay. Now, irregular reflection. So irregular reflection occurs when a beam of light falls on a rough surface. ठीक है. So जो irregular reflection है ये तब होगा जब when a beam of light falls on a rough surface, जैसे ये वाला जो surface हम लोग देख रहे हैं, so this is a rough surface. इस surface में जो reflection होगा that will be irregular reflection. ठीक है. So irregular reflection occurs when a beam of light falls on a rough surface such as the wall of a room. तो हमारे घर में जो wall है उस wall पे जो because the surface it looks appears to be smooth but it is not very smooth, वहां पे है ना, वहां पे जो reflection होगा that will be an irregular reflection. The page of a book or any other object which is around us, generally उन सब से जो reflection होता है वो irregular reflection ही होता है. ठीक है. So although the wall of a room or the page of a book appears to be smooth, but actually it is quite uneven, having many small projections over it. ठीक है. तो इस तरह से आप projections उसमें देखोगे, जो uneven surface है इसमें projections होंगे. So although the wall of a room or a page of a book appears to be smooth, but actually it is quite uneven, having many small projections over it. So in this figure where you are seeing this irregular reflection, light rays falls at different points on a rough surface and each ray gets reflected from it obeying the laws of reflection of light. Due to uneven surface, at different point, light rays get reflected in different directions. Because हर point पे जो जो हमारा ये नॉर्मल होगा हर पॉइंट पे अलग होगा क्योंकि सरफेस ही अनइवन है. तो उसकी वजह से जो रिफ्लेक्टेड लाइट होगा ना दैट विल आल्सो बी इन डिफरेंट डायरेक्शन, दैट विल बी नॉट पैरेलल एज इन द केस ऑफ रेगुलर रिफ्लेक्शन. सो due to uneven surface at different points light get reflected in different directions and give rise to the diffused or irregular reflection. As a result, the reflected light spreads over a wide area and it does not follow a particular direction. So, जो reflected light होगा, that will be distributed in the wide area. It will be spread over the wide area, and light it will not be the condition where light is reflected in a particular direction only. तो because ये light wide area में spread कर जाता है, तो ये जो reflected light है, it can be seen from everywhere, and that's why रूम में आप कहीं भी खड़े रहो एक तरफ लाइट जलती है तो सारा रूम ही जो है लगता है कि सब पे यूनिफॉर्म लाइट है पूरे रूम में. सो वो दैट इज बिकॉज क्योंकि डिफ्यूज्ड रिफ्लेक्शन हो रहा है, हर डायरेक्शन में लाइट जा रहा है, तो कहीं से भी हम बैठ के देखेंगे तो हमको उतना ही जो है ब्राइटनेस दिखेगा वॉल में. सो इट इज द डिफ्यूज लाइट ऑब्टेन okay. So it is the diffuse light obtained by reflection from various uneven surfaces which enables us to see the objects around us. ठीक है. So ये जो diffused reflection होता है ना, तो वो diffuse light का जो reflection है उसके वजह से जो various uneven surfaces से diffuse reflection होगा उसके वजह से it enables us to see the objects around us in a proper way, right? Now some more reflections related, some more terms is related with reflection. Now there are certain terms related with reflection. First is incident ray. So the light ray striking a reflecting surface is called the incident ray. Right. So light ray which strikes a reflecting surface is called the incident ray. Point of incidence, the point at which the incident ray strikes the reflecting surface is called point of incidence. So जैसे अगर हम लोग ये फिगर की बात करें, Okay, let's say this is a mirror. So incident ray जहाँ पे जाके, so the ray which goes and strikes the mirror, right? So light ray striking a reflecting surface is called incident ray. ये हो गया हमारा incident ray. ठीक है, जिस पॉइंट पे ये जाके स्ट्राइक कर रहा है, दिस पॉइंट इज पॉइंट ऑफ इंसिडेंस. ठीक है, रिफ्लेक्टेड रे के बारे में बात कर रहे थे. द लाइट रे ऑब्टेन्ड आफ्टर रिफ्लेक्शन from the surface in the same medium in which the incident ray is traveling is called reflected ray. तो यहाँ पे नीचे वो फिगर भी बना हुआ है जिसके बारे में हम लोग बात कर रहे थे ना. नॉर्मल क्या है? द परपेंडिकुलर ड्रॉन टू द सरफेस एट द पॉइंट ऑफ इंसिडेंस इज कॉल्ड द नॉर्मल. तो जैसे यहाँ पे ये वाला जो रे है जो स्ट्रेट परपेंडिकुलर है सरफेस के, वो हमारा नॉर्मल हो गया. एंगल ऑफ इंसिडेंस क्या है? द एंगल विथ which the incident ray makes with the normal at the point of incidence is called the angle of incidence. It is denoted by letter I. फिर है हमारा angle of reflection. So the angle which the reflected ray makes with the normal at the point of incidence is called the angle of reflection. It is denoted by letter R. Then we have plane of incidence. The plane containing the incident ray and the normal is called the plane of incidence. Then we have plane of reflection. So the plane containing the reflected ray and the normal is called the plane of reflection. ठीक है. So ये हमारा इंसिडेंट रे हो गया, ये हमारा नॉर्मल हो गया जो परपेंडिकुलर है, ये पॉइंट ऑफ इंसिडेंस हो गया, ये रिफ्लेक्टेड रे हो गया. एंगल मेड बाय इंसिडेंट रे एंड नॉर्मल इज एंगल ऑफ इंसिडेंस. एंगल मेड बाय द रिफ्लेक्टेड रे एंड द नॉर्मल इज एंगल ऑफ रिफ्लेक्शन. एंड दिस प्लेन, ये जो हमारा कंप्यूटर स्क्रीन का जो प्लेन है, लैपटॉप का या जो भी स्क्रीन देख रहे हो, वो प्लेन जिसमें इंसिडेंट रे, रिफ्लेक्टेड रे और नॉर्मल तीनों एग्जिस्ट कर रहा है, उसको हम लोग प्लेन ऑफ रिफ्लेक्शन कहते हैं. So in figure 7.3, MM1 is a plane reflecting surface, say a plane mirror, kept perpendicular to the plane of paper. A light ray is incident in the direction AO, okay, at the point O on the mirror. It is reflected along the direction OB. Thus, AO is the incident ray, O is the point of incidence, and OB is the reflected ray. Let ON be the normal drawn to the surface MM1 at the point O. तो ये जो ON है ये हमारा normal हो गया. Be the normal drawn to the surface MM1 at the point O. The angle I, which is equal to angle AON, which the incident ray makes with the normal, is the angle of incidence, and the angle R, which is equal to angle BON, which are reflected ray makes with the normal, okay, is the angle of reflection. The plane of paper is the plane of incidence. जो हमें पेपर का प्लेन दिख रहा है, अगर बुक है, अगर स्क्रीन है, तो प्लेन ऑफ द स्क्रीन is basically the plane of incidence. अब लॉ ऑफ रिफ्लेक्शन इसी पे डिफाइन हुआ है. सो द लॉ ऑफ रिफ्लेक्शन So a light ray obeys the following two laws while reflecting from a surface. These are called the law of reflection. दो law of reflection होता है. एक law of reflection है कि angle of incidence I is equal to angle of reflection R, और दूसरा law of reflection है कि the incident ray the reflected ray and the normal at the point of incidence all lie in the same plane. Okay? So a light ray obeys the following two laws while reflecting from a surface. These are called the law of reflection. तो एंगल ऑफ इंसिडेंस आई, जो एंगल आई है, इज इक्वल टू एंगल ऑफ रिफ्लेक्शन आर. सो एंगल आई इज इक्वल टू एंगल आर जो है, ये हमारा पहला लॉ ऑफ रिफ्लेक्शन. तो ये अगर हम लोग फिगर देखें तो एंगल ए ओ एन, ये वाला एंगल आई इज इक्वल टू एंगल आर हो गया. उसके अलावा दूसरा जो है, द इंसिडेंट रे, द रिफ्लेक्टेड रे एंड द नॉर्मल एट द पॉइंट ऑफ इंसिडेंस लाई इन द सेम प्लेन. सो उसी फिगर में AO, ON एंड OB आर इन वन प्लेन, दैट इज द प्लेन ऑफ पेपर. Now reflection of a ray of light normally incident on a plane paper. तो अगर कोई जो मिरर पे नॉर्मली इंसिडेंट होगा, मतलब परपेंडिकुलर टू द सरफेस, वो उसी डायरेक्शन में वापस रिवर्ट हो जाएगा. सो यहाँ पे एंगल ऑफ इंसिडेंस जीरो होगा, क्योंकि नॉर्मली इंसिडेंट है, तो नॉर्मल से जो एंगल बनाएगा इंसिडेंट रे जीरो है. सो फॉर अ रे इंसिडेंट नॉर्मली ऑन अ प्लेन मिरर, the angle of incidence I is equal to 0 degree. Therefore, the angle of reflection R is equal to 0 degree only. Thus, a ray of light AO incident normally on a mirror is reflected along the same path OA. That is, it retraces its path as shown in the figure. Now, formation of image by reflection. So, from each point of an illuminated object, so from each point of an illuminated object, rays of light travel in all directions to find the position of image of an object formed by a plane mirror after reflection. We need to consider at least two rays of light incident on the mirror from a point of object. ठीक है. तो अगर हम लोग को कोई इमेज बनाना है, तो इमेज बनाने के लिए हमें दो रे चाहिए. दो रे जो रिफ्लेक्ट करके जहां पे मीट करेंगे, वहां पे उस ऑब्जेक्ट का इमेज बनेगा. टू फाइंड द पोजीशन ऑफ इमेज ऑफ एन ऑब्जेक्ट फॉर्म्ड बाय अ मिरर आफ्टर रिफ्लेक्शन, वी नीड टू कंसीडर एटलीस्ट टू रेज ऑफ लाइट इंसिडेंट ऑन द मिरर फ्रॉम अ पॉइंट ऑफ ऑब्जेक्ट. तो एक पॉइंट से दो इंसिडेंट रे आएगा मिरर पे, वो रिफ्लेक्ट करके इंसिडेंट रे जहां पे मीट करेगा, उस पॉइंट का इमेज वहां पे बनेगा जहां पे ये रिफ्लेक्टेड रे जाके रिफ्लेक्ट कर मीट कर रही. Each incident ray gets reflected obeying the law of reflection. The point where the two reflected rays actually meet, or they appear to meet when produced backward, gives the position of image of that point of object. ठीक है. So जितने इंसिडेंट रे हैं, each incident ray, okay, so each incident ray gets reflected obeying the laws of reflection. The point where the reflected rays actually meet, or they appear to meet when produced backward, gives the position of image of that point of object. Thus, we can obtain the position of image of different points of the object by joining these points. Complete image of the object can be obtained. तो हर पॉइंट का एक पॉइंट ऑब्जेक्ट मानेंगे, जो ऑब्जेक्ट का जो एवरी पॉइंट विल बी कंसिडर्ड एज अ सेपरेट पॉइंट ऑब्जेक्ट, और उस हर पॉइंट ऑब्जेक्ट का जो इमेज जहाँ पे बनेगा, उन सारे इमेज को जब हम ज्वाइन, हर सारे पॉइंट्स को जब हम ज्वाइन करते हैं, तो पूरा इमेज हमें मिल जाता है उस ऑब्जेक्ट का. नाउ देयर आर टू टाइप्स ऑफ इमेजेस, राइट. So types of images. The image can be of two types. One is called real image and the other is called virtual image. So real image क्या होता है? The image which can be obtained on a screen is called a real image. So that image which we can see on a screen, which we can take it on a screen, is called a real image. क्योंकि actual light rays meet कर रही हैं, तो actual light rays जहाँ पे meet करेंगे वहाँ पे real image बनेगा. So image which can be obtained on a screen is called real image. It is formed when light rays after reflection actually intersect. So it is inverted. For example, so real image is always inverted, and virtual will be always erect. For example, for a distant object, the image formed by concave mirror is real. So अब हम लोग वर्चुअल इमेज पे आते हैं. द इमेज विच कैन नॉट बी ऑब्टेन्ड ऑन ए स्क्रीन इज कॉल्ड अ वर्चुअल इमेज. तो एक्चुअल लाइट रेज यहाँ पे नहीं मीट करती हैं. लाइट रे को जब पीछे की तरफ एक्सटेंड करते हैं तब इट अपियर्स टू मीट एट दिस पॉइंट. ठीक है. So it is formed when light rays after reflection do not actually intersect, but they appear to diverge from this image. ठीक है. Geometrically, they intersect when they are produced backward. It is erect. So virtual image is always erect. For example, the image of an object formed by a plane mirror is always virtual and erect. By a convex mirror is always virtual and erect. और concave mirror में जब वो फोकस और पोल के बीच में होगा तब फिर जो है वो वर्चुअल एंड इरेक्ट होता है. अदरवाइज हर पॉइंट पे रियल एंड इन्वर्टेड होता है. सो now distinction between a real and virtual image. So if you see this, where is this going? Just a second. So distinction between a real and a virtual image. A real image is formed due to actual intersection of the reflected ray, and virtual image is formed when the reflected rays meet if they are produced backward. Real image can be obtained on screen, virtual image cannot be obtained on screen. A real image is inverted with respect to the object, and virtual image is erect with respect to the object. Example of virtual image is image of an object formed by plane mirror or by a convex mirror. And यहाँ पे example होगा image formed by a concave mirror when the object is kept far. तो जैसे यहाँ पे लिखा हुआ है ना. So for example, for distant object, the image formed by a concave mirror is real. So you can copy and put the example here. Now, image of a point object formed by a plane mirror. So in this figure, हम लोग एक point object का image बना रहे हैं. So let's say the point object O is placed above the mirror. So यहाँ पर से we saw that we discussed that we should have two rays, two incident rays. So one incident ray is, let's say, OB, and the other incident ray is, let's say, OA. So this incident ray OB and OA, they get reflected from the mirror. Right? So both these rays get reflected from the mirror in different directions. And when these rays are, extended backward, they appear to meet at a point. Okay, they appear to meet at a point, and this point is, so इधर तो डाइवर्ज कर रहा है, इधर तो मीट करेगा नहीं रियल साइड में, है ना. वर्चुअल साइड में जो मिरर के बैक का जो पोर्शन है बिहाइंड द मिरर, this when they are produced in a backward direction, they appear to diverge from this point. ये जो रेज हैं ये क्या हो रही हैं, ये appear कर रही हैं इस पॉइंट से डाइवर्ज होते हुए. सो ये जो इमेज है ये वर्चुअल इमेज है, फॉर्मेशन ऑफ ए वर्चुअल इमेज. So in figure 7.6, let MM1 be a plane mirror in front of which object O is placed. So from the object O, rays of light travel in all directions. To show the formation of image by the plane mirror, we consider two rays from the object O as discussed. So to show the formation of image by the plane mirror, we consider two rays from the object O which fall on mirror MM1. Okay. Let OA and OB, इसको उधर ऊपर ही रख लेते हैं. So let OA and OB be two rays incident from the object O which gets reflected from the mirror MM1 in direction AC and BD respectively, such that angle CAN1 is equal to angle OAN1. तो ये जो angle है CAN1 and angle OAN1, these are equal. So यहाँ पे जो ये जो एंगल ऑफ इंसिडेंस है एंगल ऑफ रिफ्लेक्शन के बराबर होगा. सिमिलरली यहाँ पे जो एंगल ऑफ इंसिडेंस है एंगल ऑफ रिफ्लेक्शन के बराबर होगा. Here AN1 and BN2 are the normals at the point A and B. So when seen from the position between C and D, the rays between C and D appear to come from some point I behind the mirror. तो ये जो rays हैं जो C और D पे आ रही हैं, it appears to be coming from a point behind them, that is point I. ठीक है. So it appears to come from some point I behind the mirror. The point I is the image of the object O. To locate the position of I, reflected rays AC and BD are produced backward, and the point where they meet gives the position of image I. The image is virtual because the reflected rays AC and BD do not actually meet at I, but to our eye, they appear to come from the point I. Image of an extended object formed by a plane mirror. So in figure 7.7, right, let MM1 be a plane mirror in front of which an extended object AB is placed from all points of the object. Light rays travel in all directions, right? So light rays तो यहाँ पे हमारे पास MM1 इज अ प्लेन मिरर. अब हम लोग एक्सटेंडेड ऑब्जेक्ट का इमेज बना रहे हैं प्लेन मिरर को यूज करके. In this figure, let MM1 be a plane mirror in front of which an extended object AB is placed. तो ये देखो ये ऑब्जेक्ट है AB which is placed on this. Now from all points of the object, light rays travel in all directions. We consider only two rays incident on the plane mirror from the end points A and B. तो हम लोग दो पॉइंट जो है ना, एक पॉइंट A और दूसरा पॉइंट B, इन दोनों पॉइंट से हम लोग रेज को कंसिडर करेंगे. इन दोनों पॉइंट को ऑब्जेक्ट मान के इन दोनों का इमेज बनाएंगे. लेट AP एंड AQ बी टू रेज इंसिडेंट. एक रे AP हो गया और दूसरा रे AQ हो गया. ठीक है. सेकेंड रे इज दिस AQ. Let AP and AQ be two rays incident on the mirror from the point A of the object, which gets reflected from the mirror as PP dash and QQ dash. तो यहाँ पे और यहाँ पे तो एक ये PP dash करके एक रिफ्लेक्टेड रे हो गया और दूसरा रिफ्लेक्टेड रे हो गया, ये हो गया QQ dash, राइट ना. उसी तरह यहाँ पर से दो रे आया BR and BS, that gets reflected. ठीक है. That gets reflected here and here as well. तो रिफ्लेक्ट करके अब ये दोनों जो रे है QQ dash और PP dash, they appear to be coming from A dash, and this ray SR, RR dash and SS dash, they appear to be coming from B dash. इन दोनों को ज्वाइन कर दोगे तो ये हमारा इमेज हो जाएगा. तो ये ऑब्जेक्ट है और ये इमेज. ठीक है. So thus B dash is the virtual image of point B. Similarly, for all other points of the object AB, virtual image are formed between A dash and B dash. Thus A dash B dash is the virtual image of AB. So thus A dash B dash is the virtual image of the object AB. It is erect and of size equal to that of the object. The normal distance of each point of image behind the mirror is same as the normal distance of the corresponding object point in front of the mirror. ठीक है? Now position of image. So let image I is as far behind the mirror as the object O is in front of it. That is, the perpendicular distance of image from the mirror is equal to perpendicular distance of the object from the mirror. Now we are doing a proof of that. So in this figure 7.8, ये जो नीचे figure आपको दिख रहा है, shows the formation of image of point object O by a plane mirror MM1. Array OF which is incident normally on the mirror gets reflected by the mirror along the same path. तो ये जो आपको रे OF दिख रहा है, ये रे जो इधर आया, ये इसी पाथ में वापस रिफ्लेक्ट हो जाता है. Same path that is along FO, that is angle I is equal to 0 degree, therefore R is also 0 degree. The other incident ray OA, इसके बाद ये तो एक रे हो गया, right? Now if we consider this the other incident ray OA gets reflected along AC such as angle OAN is equal to NAC, where AN is the normal drawn at the point A on mirror MM1. The reflected ray FO and AC, ठीक है, ये जो FO और AC जो reflected ray है उनको पीछे की तरफ extend करेंगे तो that will appear to meet at a point I where when they are produced backward. ठीक है. The point I is the virtual image of the point object O. We are to prove that, now we have to prove that IF is equal to OF. ठीक है, ये हम लोग को सबसे पहले प्रूफ करना है. Now for the incident ray OA, अगर ये हम लोग incident ray OA consider कर रहे हैं, for the incident ray OA reflected as AC, angle OAN is angle of incidence, angle CAN is equal to angle of reflection. So by the law of reflection, angle of incidence is equal to angle of reflection, or OAN is equal to CAN. But OAN is also equal to AOF. अगर alternate interior angles देखोगे तो ये जो OAN है और ये AOF है, ये वाला जो angle. So basically this angle and this angle, this is going to be same, है ना? Alternate interior angles. So angle OAN is equal to angle AOF and angle CAN is equal to AIF. तो ये जो हमारा AIF है, ये वाला एंगल है ना, और एंगल CAN, एंगल R, ये दोनों इक्वल हो जाएगा. ठीक है, इस AIF, दिस इज कॉरेस्पॉन्डिंग एंगल. तो इससे आ जाएगा AOF is equal to AIF. Now consider a triangle AOF and AOF and MIA basically. AOF and AIF. Okay. Angle AOF is equal to AIF and AFO is equal to AFI. Which is 90 degree. and FA is the common side, so therefore triangles AOF and AIF are congruent, तो उससे हमारा OF is equal to IF हो गया. Now since OF is the normal from the object O on the mirror, the normal distance of the object from the mirror is equal to the normal distance of image from the mirror. So इससे ये prove हो गया कि the image is situated on the normal drawn from the object on the mirror and it is as far behind the mirror as the object is in front of it. ठीक है. सो यहाँ पे हम लोग रुकेंगे यहाँ तक करके. इसके आगे हम लोग नेक्स्ट क्लास में करेंगे. थोड़ा सा ही है इस वाले पार्ट में. उसके बाद बेसिकली ये चैप्टर थोड़ा सा बड़ा है क्योंकि इसमें हम लोग को स्फेरिकल मिरर्स के बारे में भी पढ़ना है, प्लेन मिरर के बारे में भी पढ़ना है. इट विल टेक टाइम बट या वी हैव कंप्लीटेड द साइजेबल पोर्शन, है ना. आप इसको यू गो थ्रू द बुक यहाँ तक और रिवाइज कर लीजिएगा. नोट्स हम सारा एक साथ ही शेयर करेंगे जब हम लोग चैप्टर कर लेंगे ये वाला.
ओके सर.
ठीक है. ओके बच्चों,
थैंक यू सर. बाय सर.
इतना ही. बाय एंड टेक केयर.